Hello and welcome to my tutorial. My name is Ashish. In short, you can call me Ash. Today I'll be demonstrating and explaining how to make your own tiny Arduino board which is compatible with DigiSpark, Tinkercad, and Little Wire, and might be some more development boards available on the market. Now, the thing you see in my hand is a clone prototype of DigiSpark. It resembles the circuit of DigiSpark as well as Little Wire and Tinkercad. All that change is made in all these three that they have different bootloaders, except DigiSpark and Little Wire share the same bootloader, that is the MicroNucleus bootloader. So wiring this up is quite simple, but sometimes can be buggy as the flux, solder flux causes short circuit. So after you complete your wiring up the board, maybe on the breadboard, possibly you can do that, but the connections will be rock solid, or else the device might be not recognized. Make sure that you use Zener diode rated 3.6 volt, or else the device won't be detected. The power bus management detects the device when the data plus and the data minus experiences voltage levels of less than 3 volts or more than equals 3 volts, not very less than 3 volts. I can say it's possibly, if we speak about it, 3 volts is minimum and the maximum voltage that we will be supplying to the data plus and the data minus. So to limit the voltage, we use a Zener diode that rated 3.6 volts. Here I am using the Zener diode rated 3.9 volts. It's all the same. We need somewhat around 3 point something volts to get started. Well, this is the ATTINY85 chip that you see in the Zoomer. Now, this resistor is a 1.5K pull-up resistor to detect it as a low-speed USB device. And underneath the jumpers, you see there are two resistors that are 6.8 ohm resistors. So all that you need to build up a VUSB circuitry is two 68 ohm resistors, one 1.5K resistor, two Zener diode rated 3.6 volts, some board strips, ATTINY85, and an IC base, 8-pin IC base. USB connector, of course, it can be any type of a USB connector you prefer. I have chosen the B-type USB connector here. So let's move on to the DigiSpark website. Let's see what is there. Okay. So, here in the website, you see many things up. We will go into the section DigiSpark, and we will select DigiSpark USB development board. Now in here, we will see about the description of the board, but we are not bothered about the description of the board. We will go straight away to the resources, where we will find the related links and the download stuffs that we really need. Over here, to build up your DigiSpark, we will first need the MicroNucleus bootloader. So we go ahead and click and download the bootloader, which I have already downloaded. It's right over here. This is the bootloader. Okay. Now let's go back to the page. Now we have all the information required to make a setup of the DigiSpark on Arduino, and they also provide a modified Arduino over here. You can see this link, DigiSpark with Arduino ID, Digistem source package, Digistem Arduino. This is a modified version of Arduino which supports DigiSpark, but nevertheless we can use the standard Arduino IDE and just add the board library from the link here, just the way it is given in the page. We just have to do that, and we will find in the board menu of the Arduino, like this over here, the board menu of the Arduino, we will have DigiSpark added by itself. Well, this is the new feature in the Arduino, available in the Arduino 1.6.5 and above version of Arduino. So I recommend you using 1.6.5. Well, let's go ahead and program the bootloader into the raw ATTINY85 to make it as a DigiSpark. Let's go ahead and do it. Zip package that we downloaded over here. Well, to program the DigiSpark bootloader in the ATTINY85, we will need a ISP programmer connected directly to the ISP pins of the ATTINY85. I'll be using here a USB ASP that I purchased recently. Well, I have already wired up my programmer with the DigiSpark, the ATTINY85 on board. So we'll go ahead and program it, the bootloader. Well, according to the bootloader specification, the high byte is supposed to be 0xDD. You can see the high byte is supposed to be 0xDD. The low byte is supposed to be the low byte is supposed to be 0xE1, and the extended byte is supposed to be 0xFE. So all that I said, high byte is supposed to be 0xDD, low byte is supposed to be 0xE1, and extended byte is supposed to be 0xFE. So let's go ahead and first program the fuse safely, because once you put the fuse inside and do some wrong fuse settings, then you can kill the ATTINY85 and cannot recover it until you have a high voltage programmer. So be careful while programming the fuse and make sure that you put the right fuse in. Let's go and do it. Okay, here I'm using a software called BitBurner, which has a spinal bone, or that is, what do you say that thing, support, which runs on actually AVR do, so it has no trouble programming any AVR chips and the programmer listed in. So I configured it to use ATTINY85 as my target chip and my USB programmer as USB ASP. As before I told you that I'm using USB ASP. Now let's go ahead and program the fuse. Let's first select the fuse settings. And I forget to tell you the software name. It's called the BitBurner. It's an open source programming software for AVR microcontrollers. You can use all the programmers listed in any of the programmer you can use. Okay, let's go ahead and see. So as I told you, the low fuse is supposed to be what? I don't remember. I guess low fuse is supposed to be E1, right? Let's check it out. I don't want to mess anything into my controller. Okay, so low fuse is supposed to be E1. So let's place there 0x E1 0 0 0 0 0 0 0 E1. It's changing. E1. Okay. So the low fuse is E1 now. Now let's do the high fuse. The high fuse was supposed to be DD. Yeah. Okay, DD. Yeah. Fuse high byte is supposed to be DD. So let's press there D, and here we go with D. Now the high fuse is DD. Now the extended fuse, which is I guess FE. Okay, let's check it once more. Okay, the extended fuse, it's FE. That's good. Now let's place it there in the extended fuse box. F and E. So we are done with the fuse. Now we will write the fuse. The right button here. We're going to write the fuse. Okay. Okay. So we're going to write the fuse. Done. It says fail to read a log. Okay. We need a modified version of AVR do to read the log bits. Actually, the log bits here is not required that much. It only failed writing a log bit. So we will verify that the fuses have been programmed correctly. We will just give a read. Okay. It's giving E1, DD, and FE. It's all fine. We have set the fuse. Now let's go and program the memory, that is the firmware, the bootloader, I mean, that we just extracted in the firmware folder, then the release folder. We will get the bootloader in the release folder. We will be programming the T85 default bootloader. Okay, we selected it. Now let's write it. Okay, we are done. Now let's close all this and let's see if the device gets detected. I've already disconnected the programmer from the board. Now I'll be connecting it to the USB port. Let's see what it says. Well, it gets the sound of detection. Well, that's okay. Now let's see what is in the device manager. Device manager. Wow. That's it. That's what you see. DigiSpark detected. Cool, huh? That's it. Now we will go into the Arduino and program the first sketch. Here I've connected a blue LED between ground and pin 0 as configuration of the Arduino ATTINY85 says pin 0. That is pin number 1, 2, 3, 4, 5. Pin number 5, which is in Arduino pin number 0. Let's go in the tool menu, board. We go and select the DigiSpark default 16.5 megahertz. DigiSpark default 16.5 megahertz. Now again we go in the tool menu. Well, okay. There's a MicroNucleus in the programmer. You'll see there's a MicroNucleus option in the programmer after installing the board menu from the tutorial that we saw last. We'll select that MicroNucleus. So we have to select two things. First, the DigiSpark default 16.5 megahertz board. Then in the programmer menu, MicroNucleus. Now done. Now let's program something. Okay. Basic, bare minimum, blink. So we will have selected the blink. We will change all the pin numbers to 13 to 0 so that we make sure that it toggles the port that is numbered as 0. Port pin numbered as 0. Now we will upload. Now you see over here the device, the software is waiting for a DigiSpark to be plugged in. So we will be plugging in DigiSpark. Okay, something wrong. Let's do that again. Please unplug the device and restart the program. Okay. Plug in the device. It says plug in the device. Done uploading. Now you see it's blinking. Isn't that cool? It's really small, white, and it can also be used as a AVR Tiny ISP. All we need is just the firmware. It's really cool. The blue LED is blinking. That's it, friends. Thanks for watching my tutorial. You will find me on www.roboticshelper.blogspot.com and my ID on Facebook is ashloverscn@gmail.com. You can also catch me on my number 7278963247, including the code India code, that is 91, that is +91 7278963247. Thank you for watching, guys.